this is Andrea Kane, and I'm here with HIT 352 Health Information Systems to talk about databases. We are now on Chapter 3. This is week 4 in the class, and so let's get started. Our learning objectives are here on the screen. These are our textbook and PowerPoint objectives. And as we talked about before, if you're looking at your syllabus and you're wondering how does that fit in, we're at 8.2, 8.3, 8.4 again. And that includes learning objectives 9.2.1 through 9.2.7, 9.3.1 through 9.3.3, and 9.4.1 through 9.4.7. And of course, those are the same objectives that we will be working on over the next 5, 6, 7 weeks. We're building as we go. So, databases. What an interesting topic. Aren't you just sitting in your chair going, yay, I can't wait to learn about databases. Okay, so if you're one of those people, sort of like me, that isn't all that excited about databases, let's see what we can learn. And again, here are the rest of our learning objectives. And we will get into use of databases because once we get going into AHIMA's VLab and EHR Go, you will be actually hands-on with databases. So never fear, we are not just about theory, we are going to get some practice in because this is a class with lab hours. All right, what is a database? It is an organized collection of data, text, references, or pictures in a standardized format, typically stored in a computer system for multiple applications. So really, it's a collection that's in a standardized format and usually stored in a computer system that is accessible by multiple applications. What are databases used for? Why even have them? Well, they facilitate data sharing. They can streamline workflow, which is awesome, by the way. They can assist in clinical decision making, provide information for decision making, especially on a managerial level, and data for data analysis. It's like having a big pantry that's full of stuff. And if you like to cook or bake, it's all there. And so let's say you decide you're going to bake some bread. You're going to make some bread and bake it. You can go in there, you can find your flour, your yeast, your salt, and all the other things that you need to make bread. But also in there, let's say you have family over or friends over and somebody else wants to make cookies. So they can go in the pantry and they can get brown sugar, regular sugar, some chocolate chips, some flour, salt, baking soda, vanilla. If you use almond flavoring, they can get all the things that they need. And let's say at the same time you have another friend who says, you know, I'm really not much of a sweet tooth person, but I have been really hungry to make this special casserole. And so I'm going to go in there and get breadcrumbs and cream of chicken or cream of mushroom soup for my casserole. I might get some, I don't know, whatever else that they think they might need to make their casserole. Maybe they're making a green bean casserole. So they want to get cans of green beans out of the pantry and all of that. Everybody can do this all at the same time and fulfill whatever they're doing, all using the same database, all using the same pantry, so to speak. So databases are really good for that. Databases are really good for knowing what you have because it's a way to go in and see, oh, I have this much of this, I have this much of that, oh, I'm running low on this, so I need to add that to the grocery list. It gives that for decision making. Let's say you're coming up on a big holiday and everybody's coming to your house to cook and make. You definitely going to want to go to your pantry and make sure you have enough. And you definitely want to make sure you're checking on the expiration dates because you don't want to have something that's way too old and way too expired in there. And so the same thing with data. You want to make sure that what you have is relevant and accurate, timely, and useful. There are people who are called database administrators, brave souls, and that is what they do, is they manage that database. And they manage what's coming in. Whoops, sorry, I went ahead too far. They manage what's coming in, what's going out, how it's being used, the quality and quantity of what's in that database, all those types of things. How it's coming in, how it's leaving. When you establish a database, you need to think about how it's going to meet the needs of the facility. And you need to know what kind of data sets are going to be required. One that's very common is UHDDS, and that's for hospital discharge information. And you can go out and see what exactly is recommended for these data elements, for these different data sets. In fact, it's a good idea to go out and look up on the internet healthcare data sets, and then you can see all the different ones. They have some for ambulatory care, some for the ED. They have, I think they have ones for other specific areas. And it's a great idea to go out and just look at what are those data elements. The helpful part about those data elements is they have uniform definitions. So they're saying that this element means this definition, and it covers all of these definitions, so that if you can call it, I don't know, I'm giving you cooking and baking examples today. Sorry about that. For whatever reason, it's on my mind. But let's just say you can call it a sugar cookie. I can call it a butter cookie. Somebody else can call it a shortbread cookie, and all of that. But if we all agree that it's going to be XYZ cookie or a white cookie or whatever it is that we agree on, we include all those definitions, and we have that consistency, so that we're not calling it all those other things. We agree on one. So when you're managing a database, you've got to make sure that the data stored within that is going to meet the needs of the user. And so a database administrator needs to make sure they can manipulate and control the data stored in there. There is something called a database management system, DBMS. And that is really important because it has data definition language, data manipulation language, data control language, and a data dictionary. Make sure that you understand what each of those 4 items are, and that those 4 items make up a database management system. You will need to know that, and not just for this class. Hint, hint, hint. Databases have to be able to handle natural language queries. They need to be able to handle Boolean searches, wildcard searches, structured query language, those types of things. This gives you a good definition of a data dictionary. And you will hear about data dictionaries if you are involved at all with information systems wherever you end up. Data dictionaries have been proven to assist in improving data quality, data integrity, documentation, data analysis, and data reuse. Not to mention, they're just plain helpful. They're a great resource that if you have a question, you can go to the data dictionary and see, oh yeah, okay, got it. This is included, and here's what it means. In a data dictionary, you have metadata, and there's also something called MASC. And I'm going to refer you back to your book for further details on those. You need to have data standards so that you're sharing data in a uniform way, and that those standards help the organization through its development. You have to have standards to be able to say, here's what we do, and here's what we provide, and here's how, and here's why. And that way people can rely on that consistency. And as the organization grows and changes, those standards will still be in place to maintain that and be able to accommodate the development that happens, whether that's development of the database, development of organizational services, whether that is maybe a merger type situation between healthcare organizations, all of that. And then data exchange standards are important. So if you're going to exchange data, how do you make sure you can do that and that the quality of the data, the timeliness, consistency, and all of that is maintained? Here's the definition for data modeling. You need to understand what that is as well. There are 3 types: conceptual, physical, and logical. Again, I'm going to refer you back to your book for details on this. Make sure that you read up on it and that you are familiar with it and you know what each definition is. An entity relationship diagram can often be very helpful with data modeling. It really helps you define the entity, the attribute, and the relationships. And this is a good example it gives you with whether or not it's a one-to-one relationship, one-to-many, or many-to-many. And you need that with data modeling. Computer-aided software engineering, that's part of data modeling, data flow diagram, and use case. And if you're not sure about these, again, go back to your book. And if you're not sure what the book is telling you, go out to the internet, take a look at these. Look them up. Relational database model. Typically, there's a table and there's types of fields. And these are the types of fields that are in there: alphabetic, numeric, alphanumeric, time and date, and auto numbering. There is normalization, the ability to query, and then there are key fields. There's a primary key and a foreign key. Again, I'm going to refer you back to your book and out to the internet on these topics because I think it's more helpful for you to go there than for me to sit here and try and describe all of them specifically. Sometimes it helps to really, you can see it, you can read it, you can hear it, you can go out and look at it. Hierarchical database model has nodes and pointers, things like organizational charts, parent-child relationship. It's looking at how things are related. I know that seems like that would be relational, and it is. Relational is relationships, but hierarchical is up and down or across. A network database looks at owners and members and also has pointers. Object-oriented database models involve text, images, audio, visual, video, or visual, other objects, and they typically use the Java language. And then multidimensional database models, an example of that would be a data warehouse. What is a data repository? That is an open structured database. So a data repository is, you've got data coming in from multiple information systems, can even be multiple organizational information systems, and it provides an integrated, multidisciplinary view of the data from a single source. Most EHRs have a data repository. And you think about some of these health information exchanges and all of that, they have a data repository. They have all this information coming in, and then it can be, from there, it can be accessed. Data warehouse offers multiple databases. So when you're going in, so let's go back. A data repository is basically one big pool of all different types of information, one very big pool. A data warehouse on the other hand, has multiple pools. And when you access it, you can get data, pull data from all of the pools, some of the pools, one or two of the pools, however you want to do it, and get it back to use. Data mining, that's the process of extracting and analyzing large volumes of data from a database. Where you will hear about data mining is the government. And they do this, if you think back to your studies about corporate compliance and the agencies that work for the government looking for fraud and abuse, the ZPICs and some of the others, CERT and others, they do data mining. They pull all this information from claims in and they run it through to identify these hidden relationships and these trends. And they may find issues, they may not, but that's what they're doing, is data mining. And that's why organizations can be caught off guard and say, well, how in the world did you ever find this? Or why in the world are you pursuing that? Well, they've been data mining and they've identified it across organizations, across states, across specialties, you name it. So techniques that are used in data mining, looking for anomalies, building association rules and seeing if something is associated, looking at clusters, looking at classifications, and doing regression analysis. I would encourage you to look at all of these very carefully and make sure you understand what they are, not just for your chapter quiz, but for your certification exam. Hint, hint, hint. Data mining, looking at analytical processing. They have the tools to be able to do this. They drill down into the data, they consolidate it, they slice and dice. And anyone can do data mining. It doesn't have to be the feds. It can be anyone. You can work in an HIT field and do this for an organization or a group of organizations and help them. If they give you access to their data, this is something you can do. You could set up and do queries and run things, write reports. I worked in quality management for a few years, and one of the things I did was I created reports, SQL reports, SQLs, and or we used to call them squirrels, because sometimes they worked, sometimes they didn't, and sometimes you thought you had one by the tail and you didn't. So SQLs, SQL reports, and you are writing these to pull data and then start to see, are you seeing trends? Are you seeing information? Can you focus down on certain things? I was looking at it more from a sepsis perspective, and how was sepsis bundle compliance with different elements or different types of patients or different settings. And that's a way that you can data mine. So it's not really just about reimbursement. It's not just about coding accuracy, although there are many things that you can find from that, but you can also do it from a quality perspective or a patient care improvement perspective. You can do it from an infection control perspective at times too. So some examples of data mining. It can be a best practice in patient care, looking at those best practices in patient care like I talked about, looking at medication adverse effects, potential fraud and abuse violations, patterns of mortality and morbidity. I also wrote SQL reports to look at all deaths and all patients that we thought had the potential for being a death, that maybe they were very severely ill in the intensive care unit, or different things. Vent, looking at vent usage and looking at ventilator-associated pneumonia, those types of things. You can also use it for patterns of denials. So if you are working in the revenue cycle with the patient finance folks and you are looking at why are we getting so many denials, you can use data mining to drill down and see what's going on. Maybe you've got a scrubber that's not working the way it should be. Maybe you've got something that wasn't mapped correctly in terms of a revenue code, or maybe there's a charge master error. It helps you identify what are your patterns of denials to start really looking, working backwards to say, okay, we've got this population. What's different? What's unique? What's standing out? What's consistent? What maybe shouldn't be there? And that is it for databases. Perhaps it turned out more interesting than what you or I anticipated. I hope you're doing well. Hope you're having a great week. Take care, and I will be back next week, which will be week 5, to talk about system selection and system implementation. And oh my, I have been through those too. I have been through those as an HIM director, and I have been through those as simply an employee. And adventurous, it is not easy times. Even the best planned system selection and system implementation can go awry. I will tell you that. So have a great week. You have some assignments. They're all case studies this week, a discussion on data dictionaries and a quiz on chapter 3, and then we will move forward. Take care.